Welcome to MEI Numerical Methods Introduction. In this video we'll be looking at errors and rounding, part 1. Now we're going to look at some terminology here, and suppose that we've made a measurement of something, and for the sake of argument suppose it's exactly 1.512, and we denote that by a lowercase x, and then if we wish to round it for some reason, so that we're rounding it to either one decimal place or two significant figures to give the value 1.5, and we're denoting that by an uppercase x, so that's our approximate value. So there's going to be a discrepancy between our approximate value and the exact value. Now we define the absolute error as being the approximate value minus the exact value, and that could be either positive or negative. And a word of warning on the notation here, because you may be aware that in mathematics generally there are two different uses of the word absolute. So in the sense that's intended here, we're saying absolute error as opposed to relative error, which we'll be defining very shortly. But it used to be the case until fairly recently that absolute error meant the application of the moduli signs. So you would talk about the absolute value of minus 2 being 2, and until recently you would refer to that as being the absolute error. So if we want to refer to the use of the moduli signs, we'll have to avoid using the word absolute and just have the moduli signs. And the relative error is just the absolute error divided by the exact value. Now suppose we have a rounded value of 1.2, and we know that the rounding is being carried out to one decimal place. Then we might be interested in knowing what the maximum possible error can be, and we can say that the true value must lie in this interval here, so it must be between 1.15 and 1.25, because everything inside that interval rounds to 1.2 and everything outside rounds to something else, to one decimal place. So in the worst case scenario, if the exact value, the little x, was at either extremity of the interval, then we'd have there'd be a discrepancy of 0.05, so that would be the maximum possible error. Now notice here the intention here really is to indicate a positive value, isn't it? So we can't use the word absolute because that's being used for something else now, but in this particular situation it would be usual to quote the maximum possible error as a positive value. Now we might wonder what the maximum possible error could be if we were rounding to one significant figure, and it turns out that there is in fact no limit. So if you have a large value, the little x of 1, 2, 3 and all those noughts there, then so if you round it to one significant figure, then the discrepancy is still quite a large number. So it depends entirely on the size of the numbers involved as to what the maximum possible error could be. So that concludes this video on errors and rounding, and we'll be looking at this topic further in the next video.